Hello everyone and welcome to We Meet at Digital Days. My name is Marie-Therese Kohl and I will moderate this presentation. We are very pleased that you took the time to participate in our virtual conference. The topic of this presentation is Shielding Options and Solutions, what best fits your design. Our speaker is Igor Rodriguez. He will hold the presentation and will answer your questions. Before we start, I would like to point out one thing. You will be muted during the presentation. This means that you cannot ask questions via microphone during the presentations. Nevertheless, you have the opportunity to ask questions during the presentation at any time via the chat function. You will find the chat function in the control panel. This presentation will be about 30 minutes long. The chat questions will be answered in a Q&A session following the webinar. There are 5 to 10 minutes in addition scheduled for this. If we are unable to answer all your questions within this time, we will answer them via email afterwards. If you still have any other questions left, just mail us at exhibition@we-online.com. We will try to answer all questions promptly. At the end of the webinar, you will be asked to participate in a feedback survey. We would be pleased if you take the time to fill out the survey and help us to improve our event. You will receive the link to the presentation in the next few days. Also, the recording will be available at our website shortly. But now, I will hand over to our speaker Igor, and I wish you an exciting
Good afternoon, everyone. And there we go. Welcome to our shielding webinar. My name is Igor Delventura Rodriguez, and I am Field Applications Engineer for Würth Electronics UK. Today, our webinar is going to be really exciting. We're going to be discussing shielding options and solutions to see what best fits your design. And as a bonus, we're going to talk about a little bit on thermal management solutions. This is today's agenda. We'll start revisiting the shielding basics, since we have to understand the basics of shielding in order to enable us to select the best solutions for each case. Also, we're going to be checking some of the parameters of shielding, and then we'll go into shielding solutions themselves and thermal solutions as well. At last but not least, we will be utilizing REDEXPERT Live in order to select some magnetic absorbers. So let's start, apologies, with the shielding basics. First thing is, what is shielding? What's the meaning of shielding? So shielding, as the own word says, is protecting yourself against something else. In our case, we are talking about electromagnetic shielding. So we are wanting to protect our devices, our products, against an electromagnetic interference, also known as EMI, that might be coming from the outside world, or perhaps it's an interference that your device, your product is causing, and we want to contain it in order to do not cause any harm to other devices or to other blocks of your own device. So shielding can be really, really important, because sometimes we will face situations that we are on the EMC lab, and perhaps we cannot modify our PCB in terms of inserting more components, or simply there will be no electronic components that will sort out that specific noise issue, and then we will be utilizing shielding. So why do we utilize the shielding materials? Well, as I mentioned, we have to fight against these nasty EMIs. So the interference, electromagnetic interference, the radiation can cause many, many issues for us. In between these issues, we can even state noise, for example, that can be either audible or visible. resonances, errors, malfunctions, or perhaps the complete halt of your equipment. And this can be really, really serious because the consequences can be, depending on the application, catastrophic. In the sense that it could even cause harm to someone, or simply it could annoy the customers, and this could incur into huge business losses for your company. So we don't want any of these. Then we'll be utilizing shielding. And our uttermost objective is going to be to achieve EMC. EMC stands for electromagnetic compatibility. So we want always to have all the devices working in harmony with each other without interfering each other. And this is something that is really necessary and more necessary every day, because we have more and more electronic devices and devices that communicate wirelessly with each other. So achieving EMC is mandatory in order to get your certifications. And as you can see here on this slide, I listed the most relevant and the most well-known certifications that you have throughout the world. Although there are many, many more, but here you can see the main ones. For example, for the European Union, we have the CE mark. For Australia, New Zealand, we have the CE check mark. Now for the UK, from 1st of January of the next year, we're going to have the UK CA, since the UK is leaving the European Union. In Japan, we have VCCI. In China, we have CCC, and finally on the US, we have FCC. So a little bit more about the basics of shielding. This is a really important consideration. Whenever you're dealing with shielding solutions, always consider every conductor, every metal, every piece of metal, a potential entry or exit doorway for EMI. The electromagnetic fields, they can be both radiated and received by these structures. And many, many things can be a possible antenna in your application. For example, cables, interfaces, apertures, pins, traces, ground planes, vias, slits, components in general, heat sinks, ICs. So we have to consider all of these as possible candidates for an interference coming in or out of your device. And talking about in or out of your device, most of the devices, most of the circuitry will be within an enclosure. Okay, so this enclosure can be and will be normally either metallic, so conductive, or non-conductive, non-metallic. Normally the metallic structures, the conductive structures, the conductive cabinets, for example, they will be really good natural shields for us. So we can take advantage of these. Meanwhile, when you have an enclosure that is either plastic, ceramic, or a non-conductive material, on the other hand, will be transparent for RF. So then you will have direct exposure to the outside world. And whenever you think about Würth Electronics shielding solutions, always bear in mind the high degree of customization that we can offer. So whenever you are browsing around our website or chatting to any Würth Electronics representative, please bear in mind that if you don't find your exact solution, we can always customize them. Okay, so don't think twice on asking us, because we can customize them in size, materials, specifications, packaging, if they're going to come, for example, reels, rolls, or boxes, etc. And we can even, in some of them, we can even etch your logo. Okay, so it's quite nice and it's quite quick. The turnaround time is quite quick to get them sorted out for you. All right, so let's dive a little bit now into the applications and solutions. where can we utilize shielding materials? So this is the classical example of a random device, where here on the leftmost of your screen, you will have a little box, which is the enclosure or the housing, however you want to call it. And this housing will have inside a PCB or various PCBs and a cable, at least one cable to either power it up or communicate with the external world. All right, so we will be breaking down in three parts: the housing itself, the PCB solutions, and also the cable shielding solutions. Your housing, if it's metallic, can act as a Faraday cage, as you can see in this curious picture here. So it can grab all the electromagnetic interference and shield you from that. But you cannot have a case that is fully enclosed. That's impossible to achieve for various reasons. First one is that you will have to have openings. Yes, openings for example, ventilation, an LCD screen, buttons, LEDs, etc. So if it was perfectly closed, you wouldn't have any EMI fields coming in or out of this device. So it would be perfectly shielded. You wouldn't have to worry about anything, but that's not the case. And even if you don't have apertures for ventilation or screen, if you simply have the fact of having a little door, it will mean that you're going to have discontinuities, because you're not able to produce a door that will be perfectly sealed. Even if you see it like having contact with the wall of the housing, you will still have something that are the irregularities of the metal. As you can see here, there is no way to polish a metal in a way that it will be completely flat. To your eyes, it might be, but at a microscopic level, it will not be. So we will have to take care of these as well, because remember, any hole can be the door for entry or exit of electromagnetic interference. So we will have to somehow have a solution in order to fill these empty spaces. Okay, and we will be doing these through our gaskets. Basically, when it comes to housing shielding solutions, we will divide them between EMC gaskets and grounding contacts. EMC gaskets will primarily fill these gaps, and grounding contacts will primarily connect the ground planes of two PCBs, or perhaps a PCB to an enclosure, to the common ground point. And both of them will have to offer you low resistance, because you want electrical continuity, and also the ability sometimes to fill these gaps that we've seen, be it microscopic or microscopic gaps. Well, so these are the four different kinds of EMC gaskets that we've got available. So the first one is called RELT, which is basically a fabric gasket with nickel copper metallization, and on the inside you have a foam. So it's highly flexible, and you can utilize it, for example, in the doors of any cabinet or something. So it requires a little bit of compression. Then you've got WGS, which is basically a woven nickel copper, which has an elastomer, sort of like a foam rubberish material in the middle. Okay, and then you've got CSGS, which is basically a contact strip gasket. And at last but not least, you have EGS, which is really similar to rubber. So it looks really, really similar to grabbing a piece of rubber. Basically, it's silicone with nickel carbon. So it's although it's a rubber, it's conductive, so it can grant you your shielding. And here I listed the main differences for you between them, so you know which one you have to choose for each occasion. So if you're into having IP protection, then you can utilize, for example, WeGS that will give you IP 20, or WeLT that will give you IP 54, or IP 68 with WeEGS. So it's the highest IP rating that we can offer you. Okay. Meanwhile, CSGS, because as you can see here on the picture, it's got slits, then it will not offer you any IP protection. Compression-wise, the champion will be EGS. You can compress it a lot. You can even utilize it on underwater applications. Next on the list is GS. You can utilize it in rough environments, for example, so it supports a good rate of compression. Then it comes LT, and finally CSGS, which withstands the less pressure amongst all of them. And the utilization of them, the recommendation is to utilize CSGS on indoor applications. You can see them really commonly in anechoic chambers on EMC labs and on cabinets and enclosures that are utilized indoors. GS, we suggest you to utilize them on rough environments where you have dust, temperatures, and you need high compression. Meanwhile, WeLT, we also suggest you to utilize it primarily on indoor environments, and EGS is the toughest of all, so it can grant you high humidity and even water submersion resistance. Well, and from the grounding contact side of things, we're going to have basically two families. The first one is called SECF, SECF, which are contact fingers. Okay, and as you can see, we have them in various shapes and sizes, and we have them with and without stoppers to give you a little bit more of mechanical resistance. And these ones will be soldered directly to your PCB. Okay. Also, we've introduced more recently SMGS, which stands for Surface Mount Gasket Shielding. So SMGS, you can see here on the bottom of the screen, we have it in different materials and different sizes and shapes, and it is an SMT part as well as SECF. So these are brilliant parts. You can even automate your production by utilizing these parts, no problem at all. They are compatible with pick and place machines. So they can grant you disconnection from the PCB towards the chassis or between two different PCBs, for example. When it comes to the cable can be, as we've seen before, an antenna, and especially because it's long. The longer the piece of metal that you have, the more frequencies it will be able to either radiate or receive. And the cable shielding has to be implemented not only on the cable itself, along the cable, but also we have to pay attention to the openings that your enclosure will have. So we have solutions for both of them, which is the good news about this. For the cable itself, you can utilize WeST, which is basically what you can see here on the top of the screen. WeST is glass fiber woven shielding. So it's conductive and it will serve as a sleeve for your cable. So you'll put your cable inside of it, and of course you will make sure that both sides of it are grounded. And how do I do that? Well, basically you have EEL, which are these earthing clips that you can see right over here, that I'm hovering the mouse over them. And as you can see per the drawing, you can utilize these clips in order to clamp the cable with the shielding to a ground plane or to the chassis, if it's metallic, of course. And you can even reinforce it, as you can see here in light gray, with conductive EMC tapes. So we have standard aluminum and copper tapes that you can utilize. Alternatively, we have a textile tape as well. So the metallic tapes are called VCF. Meanwhile, the textile tape is called VTS. And last but not least, to take care of the opening for your connector on the enclosure, we have VLTS, which is the same conductive fabric that we have on VLT. And we have also another accessory. Well, actually, you can consider the tapes as accessories as well for general shielding. You can see some examples here of someone utilizing copper tape on a guitar where the amplifier sits. And here is a drive. If I'm not mistaken, this is a CD drive, an old CD, DVD drive, that it has got some aluminum shielding tape here. This is the inside of a laptop where you can see there's plenty of copper tape on it. With the textile, you might ask, why do I have also this textile tape as well? Textile tape is more flexible. So, for example, you can do these flex flat cables, and you can wrap them around with this tape, and then they'll be shielded. You'll create a mini Faraday cage for them. Okay. And last but not least, we have VLS here on the bottom of the screen. VLS is a conductive foam that looks like a really malleable rubberized foam that you can utilize it. For example, on these three last pictures, we are seeing examples of these in order to build mini Faraday cages, be it on mobile devices or around on the back of an LCD screen, for example. So it's really flexible, and it can give you, just to give you an idea, VLS can give you attenuation up to 18 gigahertz and a good attenuation of 64 dBs according to our measurements. With grounding, we also have the earthing belts. This is the name of the family, earthing belt. And it simply connects your PCB to your enclosure or two different parts of an enclosure, for example, to give electrical contact. And another thing that is really important when it comes to shielding is to bear in mind corrosion. We have something that's called galvanic corrosion, that basically is a reaction that happens between two different metals when they have an electrolyte around them. And with electrolyte, in a few words, I mean humidity or even water. They can be the rain, or for example, the splash from a river or a sea or a waterfall. These will catalyze this reaction, and it will end up corroding a metal. So if you want to make sure that your shielding solutions will have a long lifespan, please always try to avoid combining two different metals that are far away from each other on this list. So, for example, try to utilize together, for example, copper and brass, but run away from, for example, utilizing silver and aluminum together. Okay. Continuing here, let's dive into board level shielding. Board level shielding, basically, we will have two different kinds of solutions. We will either go towards the route of shielding cabinets. So shielding cabinets are little metal cans that you will place over a specific IC, a specific component, or a specific block of circuitry that you want to protect. And basically the shielding cabinets, they will divide into two different categories: the classic ones and the brand new introduced seamless ones. So the shielding cabinets, we call them FSFS, and the new ones, FSFS seamless. The difference between them is going to be the frequency up to what they can work. Basically, the seamless cabinets, they don't have openings, as you can see here. They are sort of stamped parts. So if you zoom in into the image on this classic FSFS, you will see some seams, some little openings. And once again, these little openings for the high frequencies there will be an entry port. And with the seamless, you don't have that. So you will be able to protect your devices up to 60 to 7 gigahertz, just to give you an idea. So this will enable even some high frequency applications on 5G, for example. And also you have some nice tools on this family for prototyping. For prototyping, you can utilize this guy over here that's called Shield Do It Yourself, or We Shield DIY, which is a pre-cut metallic sheet that you can bend and you can form anything you want with it, right? And then you can place it quickly on your prototype PCB and without too much effort by combining it with this shielding cabinet clips, WSHC clip, which you can hand solder on your PCB. So you will have your prototype done quite quickly when it comes to shielding cabinets. And then once you're happy with the solution, you just get in touch with us and we can do the custom shielding cabinet for you. Okay, so the second part of the solutions that we're going to talk a little bit more about them right now are the magnetic shielding solutions, which we have three. We FAS, we FASTC, and we FSFS. So the main difference between them is how they're going to work. We FAS stands for flexible absorber sheet. So it's basically ferrite material in the form of a sheet, and that is highly flexible. So this material will work exactly as a ferrite works, by absorbing the magnetic field and dissipating it on the form of heat. And you can utilize this on many applications. It's like the sky is the limit with this thing, and it can absorb quite a lot of energy for you, and in a quite broad band. And basically, you have also FSFS, which stands for flexible sintered ferrite sheet, which works more like a reflector. Both of them will have their own rates of reflection and absorption in different frequency ranges, but FSFS, you will utilize it mostly on NFC, RFID, and wireless power applications. On NFC and RFID, basically, it will give you more range because it will be reflecting back that energy from the RFID module. And on the wireless power applications, it can either protect other devices that will not get that magnetic field from your transmitter, or it can make your device more efficient because it will raise the Q factor. It will concentrate more the energy towards the receiver. And last but not least, we have here we pass TC. TC stands for thermal compatible. So this ferrite absorbing sheet has a special characteristic that it will not act just as an EMI shielding, but it will also have good thermal transmission as well. So it will keep your components cool. And talking about keeping the components cool, you will see that on the next slide, we'll touch a little bit on thermal solutions. But before that, there is a really important information about this kind of solution, is that you can utilize it either on the PCB itself, because they are not conductive. You can put it literally over components and over the traces, or you can utilize it on the enclosure itself. Okay, it will give you a really good protection. And there we go with the thermal solutions. The thermal solutions, basically, we will have two. We FASTC, that we discussed a little bit about it. And look at an example here. You can sandwich basically the we pass TC in between a CPU or MOSFET or any other component that is noisy or susceptible to noise, and its heatsink. Without this, the heatsink would turn into an antenna. So it will do both jobs for us. It will dissipate efficiently the heat. It will transmit the heat from the CPU surface towards the heatsink in this example. And at the same time, it will shield you. Brilliant, isn't it? But if your issue is just thermal, then we have TGF, which is our thermal gap filler. So it has a really low thermal resistance, so a really good thermal conductivity, and it has the ability of filling those micro gaps. So it will help getting rid of the heat of your components in no time. All right, so now let's go to the last bit of our webinar, and let's talk a little bit about REDEXPERT, because not so long ago we have introduced a new module on REDEXPERT that allows you to choose the best EMI magnetic shielding solution. So if you go to REDEXPERT, let's go there. You open my REDEXPERT here. Use my REDEXPERT. So if you go to redexpert.we-online.com, you will land on this page. And on this page, what you can do is that you can click here on products, and you will go to the first column here, EMC components, the last option, which is magnetic shielding, EMI patch. So I've put together, meanwhile it loads, I've put together for you all a little example. And this is our scenario. We're having issues with radiation, with interference, EMI, between 160 megahertz and 240 megahertz. And we went to the EMC lab, obviously, and we found that we have to attenuate at least 12 dBs, reference to 50 ohm impedances. And the thickness of our solution must be under 0.45 millimeters. So let's do this together. And by the way, when you have these, the copy of this presentation, you'll be able to just click here on this link and access the solution that I will give you in a second. So this is the initial screen of REDEXPERT for the magnetic shielding solutions, where we can see various things such as the complex permeability, mu dash and mu double dash, which represent basically reflection and absorption levels. And also we can see here the attenuation that we can get out of these parts across the spectrum of frequencies. Quite nice. And let's start our example. To start with, I'm going to use like an advanced tool here in REDEXPERT, which are these markers. I'm going to click on this marker here and drag it, and I'll put a marker on the first frequency, which is 160 megahertz. And then I will create a little filter. I'll hover the mouse here, click on the filter icon, and I'll create a filter that I'm going to drag this top triangle here to the top of the graph. It will tell REDEXPERT that the attenuation here can be any value, like any maximum value, and the minimum value I'm going to set as 12 dBs here. Now I'm going to add another marker at 240 megahertz, which is our second frequency, by clicking the plus button here. So there we go. There is a second marker. Let me drag here this marker, and let's put it on 240 megahertz. And now let's add finally another filter on this marker. Click here on filter, and once again, the top, let it refresh. The top triangle, I'm going to drag it to the top, and the bottom triangle, I'm going to click on it, and I'll set here at least 12 dB. Okay, the job is almost done. The only other variable that we have is the thickness. So we come here to the thickness filter, click here, and let's select here on the maximum 0.45 millimeters. And job done. This is my solution. I've got here 4 different part numbers, which are actually the same, the very same material, but they are just different sizes. And that's it. You can either select your size here, or you can get in touch with us and just hand over one of these part numbers and tell us, look, this is the drawing that I need with holes, without holes, on this shape and everything. So job done. Easy, isn't it? All right, so now let's open up for questions.
Yes, right. Thanks, Igor, for your interesting presentation. Now we would like to turn our attention to your questions. So you can enter them in the chat function in your webinar control panel. Igor, let's have a look to the first question. Does it make sense to use the both shielding methods together, electrical and magnetic?
It can make. It all depends on the case and the approach that you want to have. For example, there will be, let's suppose that I have, I don't know, this remote control. It's plastic, right? It's plastic. So, for example, it makes nothing if I utilize a gasket here, for example, around it, because it's going to be plastic here and here. So for RF, it's going to be transparent. So in this case, it would make more sense, for example, utilizing a board level solution, a shielding cabinet. Perhaps I haven't got space here for a shielding cabinet, so the WE-FAS could be a solution, and so on and so forth. It's the analysis is case by case. But that question was really good. Thank you very much for this question. And this question is really good because there is an important detail always that you have to bear in mind when you're utilizing the conductive solutions, the metallic solutions. They all have to be always connected to ground, else they won't work. On the other hand, the magnetic solutions, they will work either connected to ground or not.
Perfect. Thanks a lot. One another question. I couldn't find a shielding on the website that has the exact size for my application. What should I do?
Oh yeah, get in touch with us, please. Drop us an email, utilize the web chat, or speak to your Würth Electronics representative, your business manager or FAE. That will be more than keen in order to arrange a custom solution for you. We just need the DXF files or any other 3D model that you can get us in order to make the exact part that you need.
Perfect. And one last question, Igor. Can I place the FSFS material directly over a PCB?
Yes, yes, you can indeed. This material is not conductive. So the FAS material, it comes with glue on one of the sides. So you will peel a little plastic film and you can glue it anywhere you like. And as it's non-conductive, there is no risk on putting them over components, for example, or the PCB itself. So yes, you can utilize it over the PCB or the cabinet, whatever you like.
Perfect, thanks. I would say if there are any questions left, we will answer them via email afterwards. But for now, we are finished with this presentation. Thank you very much for your attention, and I hope you enjoyed our presentation. The next presentation topic is DC-DC input filtering. Watch out, instability is about. Design criteria and pitfalls of input LC filter for a DC-DC regulator. The presentation will start at 3 p.m. See you there and enjoy our digital days today. Goodbye.
Bye. Thank you, everybody.